All right, I want to thank everybody for joining us for today's webinar entitled Agilent OpenLab's CDS for Compliant Analytical Labs to ensure data integrity, security, and traceability. Today's presentation is brought to you by Astrix, and I'll introduce our great speaker, Kiki Martinez, in just a moment here. Before we get into the content and before we get things kicked off, I do want to take a moment and share a little bit with all of you about who Astrix is, what we're doing as far as these webinars go, and what we do within this space. We can go to the next slide, please. So as far as the company goes, Astrix, so we put on lots of content, we put on lots of these great webinars, we bring in thought leaders and speakers from throughout the lab informatics and R&D space. Who we are as a company, well, for over 25 years, we've brought a very unique breadth of highly specialized services, processes, and technology that has enabled us to be a leader in helping companies transform the way that science-based businesses succeed. A couple of fast facts about us as a company. We were established in 1995, and we work with a lot of different technologies in the space, but are vendor and platform agnostic. We operate from locations throughout the US and overseas and have over 1,200 employees. Proud to say that over 90% of those team members hold advanced science degrees, so we are very much a science-based business. Our headquarters are in beautiful Red Bank, New Jersey, and some of the client sectors that we work in could be everything from startups up through Fortune 1000. Of course, they're going to be life science, but also within chemical and CPG. We also work with government agencies, and then we also work with research institutions. So that's just a little bit of the type of work we do, a little bit of background about the company. We can go to the next slide, please. And what I do want to do is talk a little bit about the scope of services. So the scope of services that we're dealing with, meaning the type of things that we do when we go in and engage with a company. We like to say that we support the continuum of scientific operations and data management. This means that we engage with companies very early on in the beginning and help them with things like strategic innovation roadmaps and enterprise architecture, where we're helping them define the technology stacks that they're going to be required to drive their business forward. From there, we get into things like data management and governance, helping to implement strategies and frameworks that maximize the value of digital assets. From there, we can get into business analysis, helping ensure people and process and technology are all optimized to help transform the way that workflows happen and solutions are integrated to meet business needs. There, we can help with development and implementation and validation of technologies. And finally, scientific and technical staffing. So when we get to the end of these projects, we can help staff technical folks, we can help staff scientific folks in the lab directly through our staffing business. So that's a little bit about the company. Let me now take a moment and introduce our speaker for today. We can go to the next slide, please. And then I'm going to turn it over to the capable hands of Kiki. Kiki Martinez is, excuse me, a delivery manager here at Astrix Technology Group. She works within the Lab Informatics Services Division, and she's focused on managing the Agilent OpenLab's CDS team. She brings over 12 years of very diverse experience in analytical instrumentation and software across multiple vendor platforms. The background is in large molecule LC-MS analysis across various applications. And I'm going to let Kiki finish her own introduction, tell you a little bit more about herself, and pick up. Kiki, I'll come back on as we get towards the end.
Yeah, of course. Good afternoon, everybody. Welcome. My background for applications in clinical biomarker research. I've also worked in vaccine development. I am very passionate about demystifying software for our customers. I really enjoy troubleshooting and supporting continued customer success and relationships. And the past 2 years, I have provided OpenLab training and support to over 50 customers as a contractor for Agilent. All right, so let's get started. So today, I'm going to present to you OpenLab CDS. This presentation is going to focus on the compliant features of OpenLab CDS. The information presented to you today is going to apply to both the individuals who will be involved with the lab. So from technicians to chemists to the lab managers and QC managers, we are going to cover important concepts for users who are using this on a day-to-day basis, as well as users who will be managing the software settings in order to ensure compliance, and most importantly, how our team at Astrix can assist you in the implementation and use of OpenLab CDS within your lab. So we're going to start with an overview of what is OpenLab CDS. What are the benefits of implementing this software in a compliant lab? Of course, you can also implement it in a non-compliant lab, but today we're going to focus on the compliant features. We'll take a look at the architecture and scalability, and then we'll review a practical example of how you can configure your system within OpenLab CDS. We'll take a look at how we can track our system activity and your file changes within the software, and how you can electronically sign your files when you review your results, and then how you can lock those results to prevent any further modifications. And then finally, we'll end our presentation with our content management solutions that provide secure data storage. Now, what exactly is Agilent OpenLab CDS? This is a chromatography data system that combines productivity. It is incredibly easy to use and also ensures data integrity. It provides our user with a single user interface from where we can control our Agilent LC, quad LCMS, and single quad GCMS, as well as any third-party instrumentation. So as you can see here, we can control any Agilent or third-party instrumentation just with a single user interface. So this means that you only need to use and learn how to use one platform. So this makes it quite intuitive and easy for your team. Now within OpenLab CDS, you'll find that we have built-in tools that provide time-saving steps. So we have reporting workflows that provide technical controls that ensure work quality, effective record management, and enhanced data security. We also support ChemStation and EasyChrome workflows, so you can import any of that data or methods within OpenLab CDS, and that enables full scalability and central data storage. We also have built-in tools like custom calculators and reporting, and that can automate your workflow and reduce any manual tasks to ensure quality and accuracy, which further ensures data integrity. Now, what are the benefits of implementing a software such as Agilent OpenLab CDS within your compliant laboratory? So we can ensure work quality, right? As I mentioned, we have built-in tools like OpenLab reporting and your custom calculator that can help ensure that your results are clear and meaningful, and most importantly, always correct. This means that you do not need to manually export your data into another program in order to perform those calculations or create reports. It can all be done within the software. You can manage your records effectively. So secure storage of your data is going to be automated. Here, using a simple and effective search function within your content management database, you can find information and you can also track any modifications that are made. When you enable audit tools, and every single file is also going to be versioned. Enhancing data security. We can identify any manipulation of our chromatography data by utilizing our audit trails. So if you enable your audit, you can identify when changes have been made to your data, methods, or reports, and we can also understand responsible when without time-stamped audit trails. We can also prevent any unauthorized access and modifications to your data. Within content management, we can store our data in secure repository that will prevent centralize our data in order to restrict access to only those individuals who have the specific privilege to access that data. Now, most importantly, we can be audit ready, right? So we can show you how to apply effective technical controls in order to implement mechanisms such as secure access control, work attribution, e-signatures, and audit trail reviews. That's what we'll focus on this presentation. So this will enable you and your team to get through the inspection faster. Now we need to stay current with our regulations, right? Today I'm going to show you some examples of how we can limit our system access. We're going to go through an example of how we can create users and groups and assign privileges in order to provide a unique level of access. This will ensure end-to-end work attribution. We can determine the who, what, where, when, and why of every single change taking place within our software. Lastly, we can validate our systems. So our Astrix team can assist you with the computer system validation so that your system is validated for its intended use to ensure that your software is functioning as expected. Okay, so let's get started here. So what are some considerations for OpenLab CDS implementation, right? So how are we going to manage our legacy data? Are we going to be importing our data into OpenLab, or are you going to maintain a workstation that is separate from the software in order to access that data? What types of instruments do you have in your lab? Do you have LCs? Do you have GCs? Do you have mass specs? Do you have single quads, triple quads? What kind of instruments do you have? So what kind of solution are you going to need? Do you have any third-party instrumentation aside from Agilent? Do you need to integrate any other software with OpenLab CDS, such as ChemStation, EasyChrome, or any other third-party software? Most importantly, what is the size of your company? How many sites do you have? How many analysts are in your lab? What are your compliance requirements? Are you a compliant lab? And very importantly is, what is your IT support and infrastructure? Do you currently have an internal IT team? Is this something that you contract out to a third party? So we can assist with understanding any gap assessments and determining what your needs are in an OpenLab CDS implementation. Now, OpenLab CDS provides great flexibility in how it can be installed. So here we can see that there are 3 types of workstations that we can begin with. A workstation at its base means that the results are going to be stored in local duration. So this is a non-compliant solution. Moving on, we have our secure workstation. Again, our results are going to be stored in a local Windows file system. You can set up users and roles and require that somebody logs in to the software, but there's still no content management database. Everything is still stored locally in your Windows file system. Now, the solution that we're going to focus on in this presentation is going to be Workstation Plus in a client-server environment specifically. Here, our results are going to be stored in a content management database. So we can restrict access and dictate who has access to your results within your content management database. They are not stored locally on your Windows file system. We are going to set up user roles and talk about how to restrict access to those results to specific projects and specific instruments. Now, another great advantage to Workstation Plus is that our data files are going to be versioned and they can be searched. So every time you hit save in the software, a new version of that file will be created. So in the client server environment, the components are going to be distributed on a number of different computers based on their function. Okay, so here we can see an example of an OpenLab server configuration. We'll go through the different solutions of content management later on in this slide deck, but this is an example of an OpenLab server or XT configuration where we have a single server to which our Agilent instrument controllers and our clients are connected. Now, the way that the software works is you are going to be accessing the software via the clients. The clients can be unlimited. You can have as many clients as you wish. You do not need licenses for your clients. Now, they can either be a walk-up instrument, or a walk-up computer that you have in your lab that users share, or it can be your individual laptop, right? So it all depends on your individual needs and setup that you have in your lab. But the clients are not the computers that are directly connected to the instruments. Those are the Agilent instrument controllers here. So your Agilent instrument controllers are going to be directly connected to your instruments. But these are not computers that you walk up to. These are going to be keyboardless, mouseless computers that control your instruments. And as you can see here in regards to scalability, you can have up to 6 LCs or GCs connected to one AIC with a 2D detector. It's all based on instrument points. So depending on the detector, it may take a number of different points. So you can have up to 6 instrument points per AIC. So here we can see that we can have 3 Agilent LCs or GCs with a 3D detector, or you can have up to 2 LC or GCs connected to a single quad mass spec. Now, what we're going to focus on are going to be OpenLab CDS compliance features. In order to fulfill our FDA rules and guidelines for compliant electronic records and computerized systems, it's going to be really important to understand the basic aspects here. So in regards to data security, OpenLab CDS provides physical protection of your data, right? We do this by being able to limit access to our system by managing our users, groups, roles, and privileges. So you can determine who has access to your content management database, who has access to which project or to which instrument. Moving on, in regards to data integrity, we provide secure data storage with our content management database. So you can give access to specific individuals to your content management database and enable audit trails. As we mentioned earlier, we have the advantage of versioning of data files, and you can configure electronic signatures for each individual project. Lastly, in regards to data traceability, you can assess who did what, when, where, and how by enabling audit trails and reviewing your activity logs. Okay, let's take a look at Agilent OpenLab CDS. Let's take a look at the software itself. We're not going to dive too deep. We're just going to look at a brief introduction of how the software looks, how incredibly intuitive it is, and some of the different interfaces that you will see within the software if you do implement it in your lab. So OpenLab CDS has 3 user interfaces. We have our control panel. That is the starting point of the software. From control panel, we can launch an instrument that will launch acquisition, or you can launch data analysis for a specific project. Within this presentation, we are going to focus mostly on the control panel. This is where most of the administrative tasks are located within the software. Okay, so here we can see within the control panel, we have 3 different views. We have administration, we have projects, and we have instruments. So let's take a look at each of those 3 components here. This is where your system administrator is going to manage your security policy. Okay, you can set up users, groups, and roles. How you do so is going to depend on whether you're using internal authentication or whether you are using Windows domain authentication. Most of our users use Windows domain authentication, meaning that you're going to log into the software with the same username and password that you use to log into your company computer. Okay, by doing so, then you can import all of the users into the software that already exists in your Windows domain. If you already have pre-existing groups, you can import those groups as well, or you can create groups within the software. Now, within administration here, you can see that there is a number of options. These options will change depending on your privilege level of access in administration. So what you see here is what a system administrator would see. Okay, so you can monitor your system activity log, you can manage your licenses, you can run diagnostics or export administrative reports. These reports allow you to summarize how your system is set up, and it's also a great way to keep a record of how your system is set up as well. So what we can assist with is what you need to consider, right? So who is going to have these administrator rights on a system level, on an instrument level, or on a project level? How should you organize your groups and assign these roles based on their job function within the lab? Now moving on to instruments, here what you will see is the lab at a glance view. So when you select the instruments route here, this allows you to view all of the instruments in your lab. So in one page, you can easily visualize the status of all of your instruments, whether an instrument is idle, whether it's running, or more importantly, whether it's in an error state. So you can easily spot, a red status and figure out why is that instrument in error state. And it allows you to easily troubleshoot from this view. As opposed to individually clicking on each individual instrument here in the navigation tree, this is a nice summary view of the status of each instrument, who is using which instrument, which sample they're on, what is the run status. Now, what do you need to consider here? You can use locations to organize your instruments. So locations are essentially folders into which you can nest instruments. Who is going to be your instrument administrator? So who will be creating and configuring your instruments and adding them to your lab? And who will have access to which instrument? Does everybody need access to every instrument, or do only specific? So that is something that you will need to determine. Now let's take a look at how easy this software is to use. So let's take a look at the data acquisition workflow. I think that the software is incredibly intuitive and easy to use. Whenever I train our customers in understanding how to use OpenLab CDS, I always feel comfortable that if I forget to tell them, how to do something, that either they can easily figure it out on their own, or they can use the Help a Learning Guide to determine how to do something. So everything, as you see here in this presentation, is included. So how do you launch an instrument, right? So here from our navigation tree, you can select any of your instruments that you have access to, and then you do need to select a project, and then you simply click launch. Now, everything in OpenLab CDS is project driven, and we'll discuss that here shortly. Once you launch an instrument, you'll see that you have a number of layouts. Each default layout will open a pre-configured set of windows, which will allow you to organize what you're viewing in regards to data acquisition, right? So from the status layout here, this is a nice summary view. So I can see my instrument status dashboard. I can begin any of my instruments or change any of my flow settings or temperature, or turn on your detector currently running. You can view your online signals or any spectra that you're acquiring. From your method layout, you can load any pre-existing methods or create new methods. You can import methods. You can open any number of windows that you see here in any of these layouts, and you can also create new layouts. Moving on, you can acquire samples either in a single sample analysis or most commonly as a sequence. So within your sequence layout, what's a really cool tool is called the sequence creation template. This allows you to create sequence templates. So let's say you would like your analyst to always run a number of blanks first, maybe a QC check, your calibration standards, and then your unknown samples. And always end your sequence again with a number of blanks so that your column is nice and clean for the next user. You can actually create a sequence template in order to provide a template for your users to fill in the sequence in that way. And that is something that we can show you how to do. So let's move on to projects. So within our control panel, there is a projects view. So here you can view all of the projects that you've created within OpenLab CDS. As I mentioned, everything in OpenLab CDS is project. If you're a previous CapStation user, you know that CapStation is more instrument organized by the here is that everything is organized by project. So you can launch any instrument, any project. Okay, what is a project? A project, yes, is going to be a set of directories that is going to be used to store all of your related information, your data, your sequences, your report templates, and your sequence templates. For each individual project, you can also specify any e-signature settings, and you can enable those audit. So if you have a mixed environment where some of your projects are compliant and some are not, you can choose for which projects you would like to enable the audit trails and e-signatures. Projects will also allow you to enable an additional level of access. So you can limit who has access to each project or project group. A project group is simply just a folder which has projects. So what we need to consider here, and this is the most frequently asked question, is what should a project be? How should I organize my project and my project groups? So what we usually recommend is that your project groups can be a timeline, right? Or they can be a department. So what I usually recommend is that your project group is maybe a quarter, right? So Q1 of 2022, Q2, Q3, Q4. And within those project groups, you can create projects based on your individual analyses. So maybe your individual target of that analysis, those can be your projects. So a project is going to store data that essentially need to be compared against each other or maybe share a common set of methods. So we can assist in determining how to organize your project groups and your projects, how to assign any rights, whether you should be limiting user access to those projects or project groups. Now, when you create a project, as I mentioned, OpenLab CDS is going to automatically create 5 folders for you in order to store your data in an organized manner. We're going to have methods, sequences, results, sequence templates, and report templates. Okay, now in your methods folder, that is where your master methods are going to be stored. As soon as you use those master methods to acquire or process data, a copy of those methods are going to be generated and placed in your results folder along with that results set. So anything that you use in order to generate those results, whether it be a method, a saved sequence, a report template, your raw data as well as your process data, all of that is going to be stored in your results set folder along with your results. So if you're ever in an audit situation and you need to replicate those original results, all the information that you need is going to be in that folder. Okay. So here we can see an example of some of the project settings that you can specify for each project. By default, the software is not going to allow you to settings. You can allow users to type their own reason or add any custom reasons here. By default, your results audit trails are always enabled by default and they cannot be disabled. And then we can also add sample and compound custom parameters. These are going to be parameters that your users are going to need to fill in for each sample in a sequence at the point of acquisition. So if you want them to maybe record your sample collection date, who collected it, what was the lot number, or anything specifically to a peak within a compound, then you can add those here at the project level and they'll be filled in when you get to acquisition. Now let's review our data analysis workflow. So we're going to cover each of these quite briefly. We're not going to focus on too much acquisition and data analysis, but let's take a look at what data analysis looks like. So you can launch data analysis for any project by clicking Start Data Analysis from the project view of your control panel. This is going to launch this data analysis interface. The first step is going to be data selection, right? So which result set do you want to analyze? So here you can see a number of result sets that we have available, the injections in those result sets. You can load any version of this data that you would like to look at. You can also import or export any of this data. You can import any legacy data, whether it be ChemStation or EasyChrome. And Agilent also provides 36 default report templates that you can import to be used within this project. So those are a wonderful starting point that we'll talk about here further on. Once you have loaded a result set, what does data processing look like? So here we can see that we can create up to 6 different types of processing methods depending on our analysis type and the type of data that we have collected. Okay, so what this means is that each of these different processing method types is going to give you different sections in your processing method that pertain to the analysis that you'd like to perform, and that of analysis that you would like. And then this is what our data analysis interface looks like. So here we can see the data that we have loaded. You'll notice that once again, we have the concept of layouts. So this allows you to view your data much more efficiently, right? So we can have a number of windows open. So maybe you want to look at your chromatogram at the same time as your injection results or next to your calibration table. It allows you to configure and customize what you're looking at here in your data analysis window. Data reporting. So once we have analyzed our data, Agilent OpenLab CDS provides up to 36 default report templates that we can use in order to create reports. So you can customize any of these reports. You can also create your own reports from scratch. Our team here at Astrix can assist you with creating these custom report templates. We can also assist you in importing any already developed ChemStation reports. If you have developed intelligent reports within ChemStation, you can import them directly into the software. Here's an example of some of the report template types that you can create. So there is wonderful flexibility within the software in regards to customizing report templates. Okay, so we can create a report template for a single injection. So that's only going to report those results. You can create as many as these as you, but you can combine data from different injections, right? You can also create a single sequence summary report. So this will allow you to combine injections, but from the same sequence. The advantage of this report template is that you can calculate sequence summary statistics. And lastly, you can create cross-sequence summary reports. So this will allow you to compare injections across different sequences. So maybe you acquired a set of samples a year ago and you want to report or create a report with samples you acquired today. You can combine those injections across different sequences and again, calculate those cross-sequence summary statistics. Now, using these report template types, There are many different ways to generate reports within OpenLab CDS. You can manually create reports. You can add the report template to your processing method. You can also add a reporting line to your sequence so that once acquisition is complete, if you have indicated a processing method, you will also have a report at the end of acquisition as well. So there are many different avenues to creating reports, and this is something that we can help you understand. The custom calculator is a tool that allows you to program all kinds of calculations to extend those default calculations that are available within OpenLab CDS. So we can assist in the creation of these custom calculations. Sometimes they can be quite complicated to understand. First, what you need to do is you need to create the formulas here in your custom calculation editor. You can launch this from your data analysis window. Add that custom calculation file within your processing method. So once your data processing is completed, it's also going to calculate your custom calculations and it will include them in your injection results. Okay. So after you have created your custom calculations, embedding them into your processing method and reporting them is quite intuitive. But we can assist in the optimization and development of these methods. Now let's run through a system setup. I'm going to run through a practical example and some of the considerations that you'll need to decide on in regards to setting up your system in a compliant lab. So the first thing you'll need to determine is whether you're going to use internal authentication or Windows domain authentication, right? So are you going to create OpenLab CDS users that are specific to the software, or are you going to use your username that you use to log into your Windows desktop? We'll talk about how to set up those users and create groups based on your job function, how to assign roles and privileges, and how to create a new role. System project and instrument admin, and what that means exactly. What can those admins do? And lastly, you need to determine, are you going to be limiting project and instrument access? So this is a question that frequently comes up is, do we need to do this? This is going to be determined by your compliance requirements and also how big your lab is. If you have 5 users, perhaps maybe you don't need to limit access. But if you have 30, 40, 50 users, and some are super users and some are only walk-up users, maybe they don't need access to everything. So let's take a look at an example of how to add users and create new users here in OpenLab CDS. Now, in each of these examples, if you were using Windows Active Directory as your authentication mode, you would also see an option here to import those users. But in this example, we're using internal authentication, so we can create users from scratch, right? So you can indicate their password. You can change these password settings here. And then you'll notice that there's more than one way to accomplish something here in the software. So at the point of creating a user, you can also assign them to a group, and you can also assign a role membership to that user at this point as well. And you can also do so from the group section or the role section. So many different ways to do the same thing. Similarly, with creating a group, you need to create the group or import them if they already exist in your directory. So in our example, what we're going to do is we have 4 users. So let's go back to our user slide here. So in our example, we're going to have 4 users. Okay, so this is just a typical example of what I see day to day. So we have Bob, who's going to be our lab manager. Olivia is going to be our chemist. She's responsible for developing methods. And then Noah and Emma are going to be using pre-existing methods, and they're going to be our technicians. So what we're going to do in this example is we're going to create 3 groups, a manager, a chemist group, and a technicians group, based on our users' job functions. And then we can limit their access to projects and instruments that they need to use based on their job function. So after we create the user groups, so we can create those 3 groups and then assign our users to those groups. You can either assign the role membership here at the point of group creation, or you can do so after the fact. So after you've created those, in this example, you can see the built-in roles that already exist in the system. If you would like to edit any of these roles, you can select them and edit them, or you can create a new role from scratch. So here you can see the privileges that are available, for example, in the built-in chemist role. Let's talk about roles for a second. So the way that roles work is we have 3 different role types: project, instrument, and administrative. So what this means is that the project roles give you privileges in the project section of control panel. The instrument roles give you privileges in regards to instrument and data acquisition, and administrative roles give you privileges in the administrative. So if you'd like to assign user privilege across 3 different role types, then you need to give the user more than one role. Okay. So here in this example, let's say we want to give our chemist privileges in order to be able to analyze data. So that would be a project role type, and you can assign as many privileges as you need to in the project section. Then we also want our chemists to be able to launch an instrument and acquire data. So we'll need an instrument role type, for example, the instrument user. So we'll give them the privilege to run an instrument. And then maybe they also need a data type. Okay. So here's an example of how you can restrict access to projects depending on job function. So here, let's say for the glycan project, I want to edit my privileges. This is going to be done by the project administrator. So maybe in this example, it's going to be done by Bob, our lab manager. So he can edit the privileges here in order to add the users to have access to this project. The role of this user in this project may differ from their role. So let's, for example, Bob, the lab manager, type across the entire software, but we don't want him available for this project specifically. Maybe he's only going to be reviewing audit trails. So you can limit specific users' roles for specific projects and specific instruments. So that can differ from their global role. So very similar to instruments and locations, you can also restrict access here. So you can either do so at the individual instrument or at the location level. Similarly, projects, you can also limit access to projects at the project group level. So if you want to limit access to the QC project group to only those working on QC projects, and to the R&D group to those only working on R&D projects, you can do so at that level as well. Okay, so very similarly here, your instrument administrator can restrict access to a specific location or to that specific instrument to those specific users that need access to this instrument, and then you can specify that user's role specifically for this instrument. So now, so what we need here is, are we going to be enabling audit trails on a project case-by-case basis? Do you need all methods within this project to have an audit trail enabled, or are you going to do so on a method-by-method basis? Viewing your audit trails. Who is reviewing audit trails? And then who needs to have access to your system activity log? So that is a new privilege that has been introduced in CDS 2.7 that you'll need to determine who has access to that system activity log and who can see it. There's a number of activity logs available within the software. So the activity log is going to be the user's footprints on the system. That's going to be saved in our shared services database here. So in our control panel, you can see that we have an activity log for instruments, projects, and system-wide. You'll see the instrument activity log is also found within acquisition for that individual instrument. Within data analysis, we have processing logs for both the injection and the result. And then within management, we also have a system activity log. Similarly, we have a number of audit trails available throughout the system. So this is different than an activity log because the user's footprint on an individual file. So the audit trail is going to be specific, going to be saved along with the file. So within acquisition, we have our audit trail, and then we have a number of audit trails in data analysis as well. But this is going to depend on whether you've enabled those audit trails or not. Okay. So let's take a look at some of these examples of what the logs look like and what they record and how they can be used. So here's an example of your instrument activity log. Record the activity of that instrument over the past 7 days. It is user specific. Okay, so in this example here, this is on a workstation, so we're not seeing individual users, but if you were in a client server environment, you would see individual users and exactly what that user has done with the instrument. So where this becomes very useful is in troubleshooting. You can attribute each action to a specific user. You have a timestamp of what's happened. So if you're looking back to see when was my sequence aborted and exactly what happened, all the information is recorded here. Okay. So this is what activity logs are used for, is for troubleshooting. Similarly, for a project, you'll find a project activity log. But the project activity log records is going to be a processing step. So whenever you launch data analysis, load a result set, and process those activities, and you can see if somebody's working on that result set. You can see if there were any modifications that were made to that result set. So that is all recorded here in the project activity log. We also have the system-wide activity log. So in administration here, in the system activity log, you can see everything for every single user, every single project, and every single instrument, and every action that was performed. Is that you have a number of filters here. So you can filter based on user, description, application, level, meaning was there a warning or an error, and then you can also change the date range here. You can also export or print any of these activity logs as well. Now within data analysis, I mentioned that we have a number of processing activity logs. So anytime you process data, you'll notice that there is a symbol here in your injection tree that shows whether that injection was successfully processed or whether there was a warning or an error. What's incredibly useful is that OpenLab CDS is a wonderful communicator. So if there was ever a warning or an error, if you hover over that symbol, it'll tell you exactly why there was a warning or an error and what you can do to amend that issue. So here we can see our audit trails within our project settings and how you can enable those audit trails. This is irreversible. So this is done in our control panel at the point of project creation. Here's where you can find your audit trails. So for example, in your acquisition here, when you launch an instrument, when you look at layout under properties, once a method has been saved, you can show an audit trail if it has been enabled. If not, you can enable it for that method specifically. Trails here under the Audit eSign tab. If they've been enabled, they'll be. What does an audit trail look like, right? So you guys may be very familiar with audit trails at this point. You can change the view of audit, whether it's all compressed or whether everything. You can search by keyword, by date range. You can add manual entries, so maybe a PM came in, or sorry, a FC came in to do a PM, or maybe you change the column so you can record anything in your audit trail. And then you can review audit trails. So here it's grayed out because we haven't reviewed all the entries. But once you review all of the entries and you have the privilege to do so, you can review your audit trails. That will change the color of your audit trail from magenta to gray. So what you need to determine is here is, are you going to be reviewing your audit trails? Who is going to be reviewing these audit trails? Records. Now let's talk about e-signature settings. Are you going to be setting up your e-signature settings for a specific project? Do you need your users to sign off on these result sets? You do need to assign e-signature privileges for those users to access, and then you determine whether that data will be locked post e-sign. So these settings are configured in the control panel for each individual project. So here you can edit your signature settings. There are specific privileges in regards to e-signing, so make sure that the people who need to e-sign result sets have the appropriate privileges. Here is a review of the e-signature settings, so you have to determine, right? So how many levels of e-signatures do you need? Are you going to enforce a specific order, and are you going to lock those results after signing? Who is going to sign up on these results? And then any additional meanings that you would like to add. What does this e-sign cascade look like? So here's just a brief example, right? So we can start data analysis for this project. And then here, you obviously need to load the results of choice. The first person that comes in may be reprocessing this data, reviewing the data, and once it's finalized, they can sign off on the data. I can ensure the third signature. Lastly, let's talk about content management. So what are the considerations in determining which content management solution you're going to select here, right? So what type of instrumentation do you have? So this means, are you only using OpenLab CDS, or you may be integrating this software with Mass Hunter in order to accommodate your triple quads? So what type of instruments do you have? What type of software do you need to integrate? What is your company's size? How many sites do you have? How many people are using the software? OpenLab data management solutions. So we have 3 different solutions available to us. We have OpenLab Server, OpenLab ECMXT, and OpenLab ECM. There are different pros and cons to each of these solutions depending on the considerations here. Now, systems that are standalone or weakly integrated can make it really difficult to collect, organize, and secure your data. So this means that those users are transferring data manually, right? So that can be time consuming and quite insecure, which increases the risk of both human error and any data breach or data loss. So when data backup is manual or ad hoc, this means that there are often no standards for employing and enforcing your data integrity strategies. So using these solutions, you can new clean install, or you're upgrading, or you're migrating, our team here at Astrix can assist you with your transition to a networked model. OpenLab ECM is going to be a lab data management software. It's going to provide centralized on-premises storage of data generated by both Agilent and non-Agilent data systems, and any other laboratory software from either a single site or multiple sites, depending on which solution we select here, right? Which one fits your needs. Now, it does provide built-in technical controls. This supports your regulatory compliance efforts. There's automated data organization, reporting, and archiving. So we can see here that OpenLab Server is the simplest solution, right? It's also, in my opinion, the easiest to use. It's quite intuitive. And then OpenLab's ECM is going to give you full functionality, but it's also one that's going to require an ECM administrator to So here's an example of an OpenLab ECM implementation on a small scale. It is a scalable enterprise content management system. So for small implementations, it is common to see an all-in-one configuration, as we see here, where we have a single compute that is used for your web server, application server, file transfer server, and your server. Would you recommend your base server is separately? But if you have a small enough system with your other servers here, and then connect it to your server, that's where your AICs and your clients are going to be connected. We can the initial example at the beginning of the slide deck. This is an example of ECM versus in the beginning, we're looking at a OpenLab server. The difference is whether you have an OpenLab server here or whether you have your web application transfer storage and database server for ECM. Now here's an example of a mid-size implementation. So for a mid-size implementation, have dedicated for certain components in order to increase your overall performance of your system. So whether you use an all-in-one solution or whether you spread out your service, that is something that we can assess. Here you can see the range of our supported analytical data integrated using OpenLab ECM. So we can integrate OpenLab CDS, CamStation, and EasyChrome, as well as Mass Hunter if you have any ICP-MSs, triple quads, or any other non-Agilent data systems as well. So that's going to be using OpenLab ECM. Now, it's important to understand, though, that within OpenLab ECM, you also need to manage your users, groups, and roles. Those are going to be separate from the settings that are specified in OpenLab CDS. So usually companies are going to assign an ECM administrator here that's either from the lab or from the IT team in order to manage these settings. Now, alternatively, here's an example of an ECM server or XT, right? So here we only have a single server to which our Agilent AICs and clients are connected to. Now, the difference between OpenLab ECM Server XT and ECM is going to be how the interface looks. You can access both of them using a web browser, but the roles for ECM Server XT are going to be managed via OpenLab CDS. Now, depending on which solution you select, we can assist you in managing these roles and privileges and determining which solution is going to be best for your system. So here's an example of what projects that are created here in OpenLab CDS. Our content browser is going to create an analogous folder into which it will house my 5 folders that are created from OpenLab CDS to store all of the data here in the secure data system, where I can dictate who has access to this data, who has access to copy, move, delete this data, who has the privilege to do anything associated with my data. So this offers a secure data storage system with full access control, right? So nothing is stored locally on your Windows file system. Everything is stored here in my content browser. All right, so this is going to conclude our presentation for today. I'm now going to pass it back to Kevin so he can announce our upcoming webinar next month. And then we can open up discussion to any questions that you guys may have.
Thank you, Kiki. Great presentation. Wonderful level of detail. So that's great stuff. Thank you again for that. Yeah, we do have webinars coming up. We've got a pretty busy fall ahead of us here. The one that's coming up next is going to be on November 16th. Title is Optimize Lab Efficiency Using Labware LIMS KPI Dashboard. So if you're if you're a Labware user or considering it or interested in that topic, feel free to join us. You could check it out. If you go right to the homepage, you'll see right on the homepage of astrixinc.com. There's an upcoming webinar section where you go into that and you'll see what's kind of slated. And you can go to the next slide, Kiki. So what I'll typically do here is we'll go ahead and wrap up the recording part. So the recording